to how check whether a given number is Armstrong or not. So let's start by creating a new project in C++. Armstrong numbers. Clicking on the console application. Okay, now we are going to save this project. Control S. We are writing using namespace std. Now we will shortly talk about which numbers are Armstrong numbers. Here we get, here we have, let's suppose 371 is a number. Here we get cubes of the digits of the number and add them, which will equivalent to the number. Then this will call Armstrong. Now the technique is that this will involve two steps. First of all, get the digits of the given number. Secondly, get cubes of the numbers of the digits. And third one, sum up these cubes. Okay, so start from the getting cubes of the digits. We will require number and remainder. In last lecture we have discussed how to get the digits from a number. We can see here while num is greater than 0, here we can get digits from the number that we called r is equal to num modulus 10. 10 is used because this is a decimal number. Okay. Now we get the last digit from the number. We will get cube of this number and add up in a third variable that called sum. Sum is equal to 0. We could say that sum is equal to sum plus r into r is to get cube of the number. Okay, now we will reduce the num by 10 to get the next digit from the number. This is the simplest technique in each lecture we have used to get the digits from the number. Now what will we have to do if sum is equal to, because in some variable we got the cubes, the summation of the cubes of the digit. Sum is equal to actual number. Here I have write the 10 because actual number here, actual number will be goes to 0, tends to 0 because we are continuously dividing it by 10. We will have to declare here temp variable that will preserve the actual number. Cout enter number scene num temp is equal to num. In these three lines we are getting the input in a number variable and preserving in this line to a temp variable. This line is used to preserve the actual. Okay, now we'll compare the actual number with the summation of its original number digits cube. If these are equal, we will write the given number is strong, else we will print the given number is not strong. Okay, so let's try to compile this code. It maybe contains error, so that here is the error. Num1 is not a variable, here is the variable num. Compile it again. Don't worry to or hesitate to compile the code. Compile it rapidly to get or identify the errors. Run it. We check it. Either 34 is a palindrome. Armstrong. No, this is not Armstrong. We check it again. 371. This is the Armstrong number. We have written in the code comment that Armstrong number is the 370 or 371. Okay, we can here see here 370. If we input to the num, this says that 371 is the Armstrong number. Here we can easily view the message from the console that 371 is the Armstrong number. So let's go back to the code. Here is the variable declaration that are required to complete the code, and this is used to get number from the user. Okay, I can write here some code to understand you. Again, if you look at the code, this is used to get reminder from the number, and this is used to preserve the number that I have already typed here. Right here, this line is used to preserve the number. These two lines are used to get the input from the user. Okay, this four line of code is used to get the remainder and calculate its cubes from the number of its digits, and this is used to reduce the number. This line of code is used to reduce the number by its digit, and the last if statement is used to check whether the sum of the digits of the cubes of the number is equivalent to the original number. Thanks.